A very good morning to all of y'all. So I hope you all are fine. So we are today starting with the new chapter, chapter number 3, atmospheric pressure of geography. So atmospheric pressure, here they are telling that in air there is weight, okay, air is also having a weight, okay. So how we will come to know, like all matters, air too has weight, okay, air is also having a weight. Atmospheric pressure is the force, okay, it is a force that is exerted by the weight of air, means this pressure or this force is applied by the weight of air. There is weight in the air, so with that weight, so it is applied on a unit of surface area, okay. So it is applied on a unit of surface area, means you can say on a small part of area. The Earth's atmosphere presses with the force of about 1.03 kilogram per square kilometer at sea level. So the Earth's atmosphere, it applies pressure, okay. So on the, you can say on the Earth, the pressure which is applied, it is of 1.03 kilogram per square centimeter at sea level, okay, means at sea level, level of sea, okay, surface of sea. So it is the strong invisible force of the Earth's gravity that pulls the air down to the Earth. So this air is pulled down or attracted towards the Earth by gravity. So the invisible force of the Earth, that is gravity, it pulls down the air to the Earth. This gives the air molecules weight. So because of that, there is weight in the air molecules, and this weight exerts a force on the solid and liquid surface of the Earth, and this force is then applied on solid and liquid surface of the Earth, okay. Anything which is in solid form or liquid form on Earth, the air, for this force is applied on that. Then the air closest to the ground is denser because of the gravitational pull. The air which is near the ground, okay, the molecules of air which is near the ground, they are denser, means they are thicker because of the gravitational pull, okay, they are having gravitational pull, and because also because the upper layers of the atmosphere press on the lower layers. So the thing which is on the lower layer, okay, so the molecules which are in the upper layer, they will also press the molecules which are on the lower layer, okay. So because of that also they are pressing and they are having force and they are having weight, okay, they are heavier, and thus more air molecules get packed in smaller area, and because of this pressure in small area, more molecules are packed. Air pressure is measured in units called millibars. So air pressure, it is measured in units, okay. What is the unit to measure air? It is a unit called millibar. It is measured by an instrument called barometer. So air pressure is measured with an instrument called barometer. A barograph is a barometer that self records changes in atmospheric pressure. What is a barograph? A barograph is also a barometer, okay. It is also an instrument with which air pressure is measured. So that self records, means it keeps automatic record if there is change in atmospheric pressure, okay, means if sometimes you can say the pressure is more, okay, sometimes the pressure is less, so it keeps the record automatic. They are having self record, means automatic record. Then an imaginary line that joins all the places that have the same atmospheric pressure is called an isobar. So you can say one imaginary line which joins all the areas with same atmospheric pressure, it is known as isobar. However, this pressure of the atmosphere is not uniform all over, means this atmospheric pressure, it is not constant, okay, means it is not constant all over, means it is not, you can say, at the same level, means in all the areas. There are various factors responsible for this. Now factors affecting atmospheric pressure. First is temperature. The higher the temperature, the lower is the pressure, and vice versa. If the temperature will be high, the pressure will be low. Vice versa means opposite. If the temperature is low, then the pressure will be high, okay. So it is opposite. As air is heated, it expands, the molecules spread out and it becomes less dense. When air is heated, okay, what happens? It expands, means it becomes larger, and the molecules, they spread out, okay. When it will take more area, it will cover more area when it will expand, so the molecules, they spread out and it becomes less dense, means it is having less weight also, and it is less thick. hot air rises because it becomes lighter and an area of low pressure is created. So when when the air is hot, the molecules they rise upwards, okay, because what happens, it is lighter, na, the molecules are lighter, so that's why they rises up, and there the what type of pressure is created, it is low pressure, okay, because the molecules are rising up because of heat, so that's why there is low pressure area. Then when air cools down, it contracts, okay, when the air it cools down, it contracts. Contracts means decrease in size, okay, getting less in size and becomes denser, because and then it gains weight also, and it becomes thicker also. As the molecules are more tightly packed, it moves downwards and exerts more pressure. So the molecules are more tightly packed, okay, then what happens, it moves downwards, the molecules they moves downwards and they apply more pressure, they are moved down with more pressure. Then altitude, at high altitude the air pressure is much lower. When the altitude means when we go higher and higher, na, okay, to means you can say to a great height, okay, so the air pressure is much lower, there the pressure is lower. The pressure of the air decreases with an increase in altitude. As the height decreases, the pressure of air decreases, okay. You can say that the mountaineers, okay, the which are you can say going on mountains, okay, which are traveling on mountains, so they are having oxygen cylinders at the back, okay, because of this only, because there the air pressure is low, okay. Then this happens because at higher altitude the gravitational pull is less, okay, so the force of attraction or the gravitational force is less that there, and less air above exerts less pressure, and the air is less, because of that the pressure is also less, and less pressure is applied. The thin air has less oxygen, the air becomes thin, na, you can say on the surface of the earth it is thicker, so on the you can say altitude the air is thin and it is having less oxygen in it, making breathing difficult, so that's why it becomes difficult to breathe. So that is why the mountaineers carry oxygen cylinders when they go on mountains expedition, means on the journey of mountains, okay, when they are going on mountains, so they are carrying with them the oxygen cylinders. Now unequal heating of the earth and the atmosphere. As the earth is spherical in shape, means the earth is round in shape, not proper round, okay, it is spherical means not proper round, you can say. The sun's rays fall at different angles, so as you can say the earth here, okay, so this is earth, or you can say this is sun, okay, so earth is round, so that's why the rays of sun, it what happens, it falls on different angles, okay, so these rays it falls on different angles and different parts of the planet. The result is that the equatorial region gets the direct rays. Here now you will say this is the equator, okay, equator is you can say just half of the earth, okay, so center point, this is the equator line, so the rays of sun they fall directly on the equator, or you can say straight on the equator, then gets the direct rays so as it receives more heat, so that's why this area is the most heated area. The hot air rises creating a low pressure. So as I told you that here because of the heat, okay, what happens, because of the heat, now here the molecules they will go upwards, okay, they will rise upwards because of the heat, and here what type of pressure is there, here it is low pressure area, and because of that the air molecules are rising upwards. Then they create a low pressure area. The polar regions get the slanting rays, the polar regions here, okay, north pole and south pole, they get slanting, okay, this is slanting rays, okay, so they are getting slanting rays. The air is cold and this creates a high pressure belt, so here you can say it is high pressure area, because here the air is cold na, so they are having high pressure area. So the molecules which are rising up from the air, they are settling here in the cold area. Then again they will move from here, again they will come in the low pressure area, again they will rise up, they will go upward. So this cycle moves like this. Okay, then rotation of the earth. The earth rotates on its axis, moving west to east. So earth is moving from west to east. Okay, then it spins fast at the equator, means it rotates fast at the here at the equator, and is slower at the poles, means on the poles it is moving slower. Then around the latitude 60 degree to 65 degree, means you can say the latitudes, okay, like this, means from here you will see 60 degree above, okay, 60 to 65 degree, and here also 60 to 65 degree. Okay, so 60 to 65 degree north and south of the equator. The rotation of the earth results in air being flung from it towards the equator. Flung means throw forcefully. Here you will see in this areas, you will see that the air, it is thrown forcefully, okay, towards the equator. Means from here, when the air is going back to the equator, it is thrown forcefully, thus creating a low pressure area there. So here also what it becomes the low pressure area. Okay, so beta, that's all for today. Okay, I hope that this much is clear to you. So rest we will continue in next video. Till then, be safe. Thank you. Have a nice day.